Welcome to Online Academy. This is George Man. Today team are going to take you through predicates and quantifiers. So we are going to do predicates and quantifiers. So team, what are predicates and quantifiers? So we are going to start with the predicates. What are predicates? So a predicate team is just a sentence with variables. Just a sentence with variables, and it will only become a statement when you substitute those variables with a specific value. So what you have for a predicate is just a sentence. For example, something like x plus 5 is equal to 7. So whenever you have this x plus 5 is equal to 7, it's a predicate. We call it a predicate or a propositional function. And as you see that we do not have its truth value, it's neither true nor false. So this one is just a sentence. For it to become a statement, it have to be something here. You have to substitute the specific value for x. For example, we can have 2 here, then we say 2 plus 5 is equal to 7. This one, you can say that it's what? It's true. It has got a truth value of true. Why? Because 2 plus 5 is actually equal to 7. We can also have a 3 here and say 3 plus 5 is equal to 7, and it will have a truth value of false, as you see here. So these ones are now statements. These ones are now statements because they've got what? The truth value. But a predicate is just only a sentence, as you see here. So a predicate can be written, can be represented by a letter. Okay, for example, you can put P here to represent a predicate, then followed by the variable P of x. Okay, so this one will be our predicate, where x is the variable. X will be the variable here. X is our variable, and then it will be P of x. That's a predicate. So team, where this variable will be coming from, it will be coming from the domain. We have what we call a universe or a domain, which will be the values where this predicate is defined. For example, here we can say that P of x is such that x is an odd integer. Okay? P of x such that x is an odd integer. So we know that P of x is true whenever we have got an x as an odd integer. So the domain, our domain will be x is an element of D, where D is our domain, but the domain will be all the possible integers. All the possible integers that we have. Then we need only odd numbers for P of x to be true, but will be extracting from the domain of integers. Also, you can have another example where P of x, you can say x, where x is an American, right? Here we are just saying, for P of x to be true, x must be an American. So the possible values for in our domain will be humans, okay? And then we look at you if you are an American or not. If you are an American, therefore our P of x will be true. So this is what we call a predicate in its domain. Okay, so the value that we put here, like here 2 and 3, these are the values which will be coming from our domain. So now we are going to talk about the quantifiers. So let me quickly grab my board off so that we can talk about quantifiers. Let's talk about quantifiers. Let's talk about quantifiers. So what are quantifiers, team? These are just words. Okay? These are just words that represent the quantity. Okay? Are just words that represent the quantity for our variables, for our predicate to be true. For example, you can have for some, for all, something like that. Those words are the one that we call as quantifiers. They will give us the quantity of variables that P of x will be true. Like for example, you can have like here for quantifiers, we've got two types of quantifiers. Basically, we've got two types of quantifiers: the universal quantifier and the existential quantifier. So we've got the universal quantifier and the existential quantifier, right? So here for universal quantifier, we use this symbol. We call it for all. And for existential quantifier, we use this symbol, which is they exist. We call it they exist. Okay, so I'm going to start with the universal quantifier. We are going to start with the universal quantifier. So what this universal quantifier do here is it actually says that for universal quantifier, it was designed to be true if, like for example, we say for all x is an element of D, our domain, then P of x. This one. This is the universal quantifier. What does it say? It says that for every value or for every x in our domain, P of x is true. This is our universal quantifier. So it was designed to be true whenever each and every value in D is actually true for P of x. If there is any value here which is not true for P of x, then this one will be false. So it is only true when all x in D are true for P of x. That's when it will be true. And it will be only false if there exists an x in D, so that P of x is not true. So it was designed to be false if there is an x in D where P of x is false. So that's all about the universal quantifier. So let's talk about the existential quantifier. So let me rub off my board so that we can talk about the existential quantifier. The existential quantifier. Existential quantifier. For this one, for the existential quantifier, here we'll be talking about some elements in our domain for Px to be true. So this one will be they exist and x is an element of D such that P of x is true. So I said we are just saying they exist, or for some we are just saying they exist in x in D such that P of x is true. So if you have our domain, from our domain, if we have only one value or at least one value for P of x to be true, then this is where we use this existential quantifier. Okay? So it was designed to be true only when there is at least one value in our domain for where P of x is true. And it is only false where there is no value in what? In our domain D, so that P of X will be true. Okay, so it is only true when there is at least one element in D, in our domain D, such that our P of X is true. Okay, so we are just going to do two examples, but we are just going to do an example for universal and for existential quantifiers. So let me see if I can have an example for you for existential and universal quantifier. Okay, let me find an example for you. So team, we've got this example which says all dogs are vegetarian. All dogs are vegetarian. Okay, so we are going to write this statement in quantifiers. Okay, so for this one, if you are saying all dogs are vegetarian, using the universal quantifier, because we've got this word all. So when you are saying for all, which means you are going to choose the universal quantifier. So universal quantifier, you're just saying for all D, for all dogs which are in what? Which are in our domain. Okay, then D is vegetarian. Okay, we are just saying for all D in our domain, then D is a vegetarian. This is how do you express it in quantifiers. We are just saying all the dogs that we have in the domain, they are all what? Vegetarian. What if here, instead of all, we've got some dogs are vegetarian, which means now we are saying there exists some dog D in our domain D, such that D is vegetarian. Just as simple as this. There exists D, which is dog D, in our domain, such that D is a vegetarian. So this is how do you express statements in quantifiers. As simple as that. So thank you for watching. In the next video, we'll be talking about the negation of these quantifiers. What will happen if I negate this? What will happen if I negate this? So in the next video, we'll be talking about the negation of quantifiers. So thank you for watching, and also subscribe to this channel if you are interested in my videos. Thank you.